and gentlemen, we are the representative of Sekolah Tun Fatimah Malaysia for Miyio 2022 competition. Hence, my team, ZAFIRAH, HAZIRAH, ALMAS AJRIYA and NURFADZLIYANNA AQILLAH with our club advisor teacher, Miss MAIZATUL NAILAH, are proud to present to you Eremoconté. Eremoconté is derived from a Latin word, eremo, which means whiz, and we refer it to our dry leaves, combined with a French word conté, which means container. Our product is made of dry leaves, tapioca starch, and sodium hydroxide. We would all imagine that Eremoconté could be a waste converter to millions of money. Even so, before things gets exhilarating, let's first take an optical canvassing of our inspiration.
Based on statistics, plastic waste produced each year, packaging, mainly of course, food plastic packaging contributes the most waste, with 141 million tons roughly each year. For your information, based on UNESCO, over 1 million marine animals are killed each year due to plastic debris in the ocean. Plastic and polystyrene suffocate marine life, such as fish, sea turtles, and marine mammals can become entangled or ingest plastic debris, causing suffocation, starvation, and drowning. Secondly, non-biodegradable materials used in food packaging. Plastic packaging is extremely wasteful and impacts Earth's ecosystem on which we depend. 9.2 billion tons of plastic have been produced, of which only 9% has been recycled properly. What are our objectives? First of all, our products seek to attain energy independence and promote efficient utilization, which we aim to no longer depend on non-renewable sources like fossil fuels by using only organic sources. Next, we aim to conserve and minimize the impact on the environment so that there will be no more water pollution or any logging operations that provide paper products. As a result, our product could protect our biodiversity and ecosystem. Finally, our product aims to improve the quality of life for all. While using Eremoconté, there will be no more smell pollution or toxic pollutants from burning plastic, which can affect serious health problems such as cancer.
Let's start our experiment. Firstly, dry leaves are shredded into tiny pieces. Then, the shredded leaves are immersed in the sodium hydroxide solution and left for 24 hours. After that, rinse the leaves several times until they reach neutral pH value. Leaves are then blended and mixed with tapioca starch. The fiber of leaves are put into a mold and shaped following the shape of mold. Then, the fiber is left under the exposure of sunlight until dried up. And finally, repeat steps 1 until 6 without adding tapioca starch. Let's take a look at the results obtained from the decomposition experiment. For the decomposition experiment, our objective is to compare the rate of decomposition of sample B of Eremoconté with plastic sample. Apparatus needed for the experiment are a container with holes underneath sample B, plastic sample, and soil. Materials needed are plastic, sample B, and soil. The first step is sample B of Eremoconté is planted in a container that is filled with soil. And lastly, plastic sample is also planted in the soil. Both samples are observed for a week.
As for the result, let's start with Eremoconté sample. We observed that the Eremoconté started to decompose on the 4th day, which we've tabulated the data in the table. As you can see, there are obvious changes from day 1 to day 6. Moreover, no changes observed for the container containing plastic samples. So here is the result. As you can see, Eremoconté contains a high rate of decomposition as it took a week to decompose completely.
Let's break down the significance of our procedures. Firstly, we carry out fiber treatment to remove coating of hemicellulose and lignin to only obtain the cellulose of the leaves. To do so, that's why we immerse the leaves in lye and grind them in the blender. It is to reduce the content of non-cellulosic binding material. Next, sodium hydroxide used in the production of Eremoconté also functions in reducing the hydrophilic property of fiber by reacting with hydroxyl groups in cellulose. It can also improve the mechanical property of Eremoconté by increasing the content of cellulose in fiber. Tapioca starch is chosen as the best binder for our product because it helps in increasing the strength and smoothness of material, making our product to look nicer in the market. It is also known for its high viscosity property, which could provide Eremoconté a firm texture to act as durable container. Tapioca starch also has a high melting point. This way, our product won't be melted easily due to the hot food or surrounding. Therefore, sticky container problems can be avoided by using tapioca starch.
We hope that our product can help to provide a better environment because less greenhouse gases will be emitted as forest destruction is reduced. Our production also can reduce pollution because our product is biodegradable. And last but not least, to reduce the usage of polystyrene and plastic in our life. As for our future improvisation, we hope that Eremoconté will emerge in various shapes and uses such as cups and paper bags, not only as a container. Moreover, we hope that we can integrate a substance that is able to decolorize our product so that it will be more presentable and convincing to be commercialized. Lastly, we hope that we can add a virtual grade coloring such as an extraction of mangosteen pericat in order to enhance commercial of mangosteen.